Okay, here's another one where we have to simplify the radical, the square root. Okay, again, the square root and the square are inverse of each other. You need to cancel those things out. So I'm going to make some squares from here. Oh, it's a tough one, but remember the divisibility rules? If it ends in an even number, you can definitely divide it by 2. If I divide this by 2, on the 3 it fits 1 time. There's a remainder of 1, so that makes this 19. And 19 it fits 9 times. Remainder of 1, so that makes this 12. And 6 times. So it should be 2 times 196. Okay. It also ends in an even number. Divisibility rules means that I can divide it by 2. If my 1st digit is a 6, it's an even number. In 1 it doesn't fit. In 19 I can divide by 2. It fits 9 times, right? That's 18, remainder of 1. That makes this a 16. 2 fits into 16 8 times. Okay, so then this will become 98. And it also ends in an even number. So by divisibility rules, I can divide by 2. It fits into the 9 4 times, remainder of 1. Then that's 18. It fits 9 times. Okay, and then 98 is 49 times 2. And we know that 49 should be 7 times 7. And 7 is also considered a prime number. We're trying to break these down into prime numbers. Prime numbers are anything that can be divided by itself and 1, which is a 2, 3, 5, 7, 11, 13, etc., etc., etc. Okay? In other words, 392 is the same thing as saying 2 times 2 times 2 times 7 times 7. Okay? And we need that because we need pairs. We need to find pairs. I see a pair right here. I see another pair right here. Why pairs? Because we're dealing with square roots. We need to be able to simplify. Means that what can you actually get the square root of? Well, we know here we have the 2 2's, so there's my pair right there. That's 2 squared, and that's under the square root. I see another 2, and that happens to be by itself. So I'm going to place that in here by itself. I see another pair of 7s. I can rewrite it as 7 squared. And you can do the same thing with the letters. You see the power of 1 for the H is an invisible 1. So it's basically just an H by itself, right? You have a J, so it's basically just a J by itself. And you have 4 Ks. 1, 2, 3, 4. But that means that I can pair them up. And I can write K squared and K squared because I have 4 of them, 2 and 2. The reason for that is that you can remove the square with the square root. So the only thing left over here is that 2, that 7, that K, and that other K. So we got rid of that square and the square root. We got rid of this square and the square root. We got rid of this square and the square root. And this one here. So anything that comes out, multiply it, that's 14. K times K is actually K squared. On the inside, I have 2, H, and J. So there's no other numbers except the 2. And the H and the J go together. And we have simplified this square root.